Hello, Legacy Savers. Today we're going to look at linear programming, which is the introduction to it. Just so you guys have an idea, when you come to class and we work on a problem together, you understand kind of what we're doing. You're going to want to have your notes, and you're definitely going to want to be listening to me right now, because there's a lot of me just talking today. What is linear programming? Well, linear programming is basically a mathematical tool for maximizing or minimizing a quantity, usually profit or cost of production, subject to certain constraints, which is basically we have limited amount of materials to use or limited amount of employee time or something along those natures. Most mathematical decisions made by management of businesses involve some form of linear programming. They want to make the most money possible with the least materials used. This was developed around the time of World War II, when we were trying to figure out how can we best maximize our use and materials and resources, and used in economics, manufacturing, production, planning, and also business management. So here is a possible linear programming problem. We have a potter who wants to make and sell serving bowls and plates. So we know that a bowl uses 5 pounds of clay. We know a plate uses 4 pounds of clay, and the potter has only 40 pounds of clay to use. He wants to make at least 4 bowls. So, just kind of like when we did our story problems with equals, with equations, let's designate X with bowls and Y with plates. So, we need to make what's known as constraints, or the limitations of what's going on. So we know that he has a limited amount of clay, right? So it's going to take 5 pounds for each bowl he makes, so we can call that 5x. And then it's going to take 4 pounds of clay for every plate he makes, which is 4y. So we know that 5x, which is the amount of clay he's going to use for bowls, plus whatever amount of clay he uses for plates, which is 4y, has to be less than or equal to 40, because he can't make more clay up out of nowhere. Well, he also wants to make at least 4 bowls. At least 4 bowls means he wants to make at the very minimum 4. So he can make 5, he wants to make 6, whatever, but he can't make just 2. So we know that X has to be greater than or equal to 4 because he needs to make at least 4 bowls. And we know that, well, he can't make negative plates. It's just not going to work. So he can make 0 plates, but he can also make up to however many plates he can make with the number of number of pounds of clay he has. So basically what we're going to do is with these, we're going to create a graph with a feasible region. What the feasible region basically allows us to do is find where the sweet spot is. So here's my constraints that we had. 5x plus 4y is less than or equal to 40. I have graphed my equation right there. And remember, that's going to be, I'm going to shade in this side of it, right? Then, I know x has to be greater than or equal to 4, so I know that I need to be on this side of the line, and I know that y has to be greater than 0, so I know I need to be on this side of the line. Now, do you see where all 3 of them intersect? I do. It's right there on my little gray line, right? Well, what that is a feasible region. The feasible region is basically where all the possible solutions intersect. Where do they intersect of all the graphs? What you're going to do with that kind of helps us know how many bowls and how many plates should this potter make. But why would we need to know this? The real big question is, how can the potter maximize his profit? Maximize the money he's getting off of this. So, what if the profit on a clay bowl is 35 bucks and a profit on a clay plate is 30 bucks? Well, to find out the amount of money he's going to make off of pots and plates, we would have 35x plus 30y, right? Because 35 is per bowl and 30 is per plate. So 35 times X would find the amount of money I'm making off of bowls, and 30Y would be the amount of money I'm making off of plates. So now, which point is optimal? Well, any point in the feasible region is going to satisfy what we want. But what's going to give him the most money? So what you're going to do is the corner point principle. Basically, in linear programming, the maximal value for profit always corresponds to a corner point. What the corner points are is basically where the lines intersect with one another. So let's find our corner points. I know one of my corner points is 4, 0, where my smiley face is on my graph. Where would be another one? 8, 0 is another where they intersect. That's where the yellow and the red intersect. Now, green and yellow, they intersect at 4, 5. Now, that's all good and dandy, but what are we going to do with our corner points, you're asking? What you're going to do then is you're going to take your corner points and take them and pop them into your profit formula to see how much money is he actually going to make if we would use that many. So at 4, 0, so that means he's going to make 4 clay bowls but 0 clay plates. He makes about $140. What about at 8 clay bowls and 4 clay plates? Well, he's going to make $280. A lot more money. He doubled his money by doubling the number of his plates. But what about that 4, 5 point? Well, if he makes 4 clay bowls and 5 clay plates, he makes $290. He's making an extra $10 off of that. So we know that the corner point of 4, 5 is the optimal point. He made the most money on there. So of course we're going to build 4 clay bowls and 5 clay plates. So therefore, the potter can maximize his profit by producing 4 clay bowls and 5 clay plates for his business. Here is the steps that we're going to follow whenever we do a linear programming problem. We're going to first read through the problem. What do we need to know? Then we're going to set up our inequality constraints. So what do we have to worry about? Do we need to worry about time? Do we need to worry about dough? Do we need to worry about manpower? Then we're going to write a profit or cost formula. So how much does it cost to make X and how much does it cost to make Y? Then we're going to graph all these inequalities and we're going to find a feasible region where they all intersect. And then we're going to use the corner point principle to find our maximum or minimum. Now, minimum is more when you're looking to minimize a cost to make, let's say, fridges or a vacuum. Something like that. When you want to make this, you want to have the smallest amount possible. You don't want to pay that as much. And that's the end of this video. See you later, Sabers.